Merry Christmas to my 4 wonderful nieces. For your presents this year, I'm giving you rocks. Let's talk about rocks. Fluorite rock is the inspiration for the name of the phenomenon of fluorescence, where illumination of a substance with short wavelength light, like ultraviolet, makes it emit light of a longer wavelength. Shine UV light on fluorite and it often glows purple, sometimes blue or green. Fluorite is also the root for the name of the element fluorine, that was first isolated from the rock in 1886. Fluorite is mostly safe, but fluorine chemistry is notably dangerous. So much so that the many chemists who were early casualties of this research would become known as fluorine martyrs. Bone and tooth enamel contain the mineral hydroxyapatite. Fluorine is used in toothpaste because it binds very strongly to calcium, making fluorite and fluoroapatite, which are more resistant to acid attack. Ruby and sapphire are the same mineral, corundum aluminum oxide, or alumina. The blue color of sapphire comes from traces of iron and titanium. The red color of ruby comes from traces of chromium. See another quick video of mine for more information on that. Aluminum is the third most common element in the Earth's crust, behind silicon and oxygen. However, aluminum metal was once considered a precious metal, as expensive as silver, because it was difficult to extract and purify. The Washington Monument was completed in 1884 and, inspired by ancient Egyptian architecture, it was capped with a 6¼ pound pyramid-shaped block of precious aluminum, the largest single piece of the metal ever cast at the time. Less than a decade later, methods were invented to mass-produce both aluminum metal and synthetic sapphire powder from bauxite ore. Peridot and olivine are two names for the same mineral, although peridot is more commonly used to refer to transparent gemstone quality samples. It occurs in rocks such as basalt that are known as mafic or ultramafic rocks, volcanic or igneous rocks that are relatively poor in silica and rich in elements like magnesium and iron. There are 4 known beaches in the world where the sand is green because it's composed of olivine grains eroded from the surrounding lava rock. Perhaps most well-known of these green sand beaches is Mahana Beach, also called Papakolea Green Sand Beach in Hawaii. Removal of the sand is prohibited. Water, heat, and high pressure transforms basalt and olivines into serpentine, or serpentinite to you geologists out there, a greenish metamorphic rock that is the state rock of California. A popular theory is that most serpentine near coastal subduction zones, like the west coast of the US, comes from ancient oceanic crust that originated from volcanic mid-ocean rifts. This oceanic rock was then transformed and deposited on the continent by tectonic activity. So if you pick up a piece of serpentine from that area, you might just be holding a piece of ancient ocean floor. Weathering of serpentine and olivine changes the color of the rock from green to reddish-brown, and releases iron and magnesium ions that can bind carbon dioxide from the atmosphere as solid carbonate minerals. In fact, prehistoric periods of tectonic mountain building are thought to have led to accelerated weathering of mafics and other silicate minerals, resulting in reductions in atmospheric carbon and periods of global cooling. Garnet encompasses a wide group of minerals with this general chemical composition, swapping the magnesium or aluminum for different elements. It can vary in color from deep red to green. The name pyrope comes from Greek for fire eye, and refers to a specific type of red-colored garnet that is also found in ultramafic rock, similar to olivine. It is a hard mineral commonly used in abrasives. Actually, I don't have much more to say here. Garnet is just one of my favorites because it's the birthstone for the month of January and can have such a deep dark color that it can only be seen by shining a light through it. What? Not everything has to be about science. Now for a few rocks that are all technically made of the same stuff. Silicon dioxide, or silica, is one of the most common minerals in the Earth's crust, and it comes in a wide variety of forms. Pure single crystal silica is quartz. There's also smoky quartz, milky quartz, and rose quartz. Citrine is orange-yellow quartz. Amethyst is purple quartz. The color comes from traces of iron and other elements and can be made deeper purple by irradiation with X-rays or electron beams. High heat will change the color from purple to yellow. In scientific terms, crystals aren't just those pretty gemstones, but any material in which the atoms or molecules are arranged in regular repeating patterns. In this sense, more materials are crystalline than you might think, including some plastics, cotton, and almost anything metal. My favorite form of crystal healing is a band-aid. You might think that crystalline rocks are faceted, like the fluorite and garnet pieces I've given you, and that anything smooth is not crystalline, which is not true. Most common rocks are polycrystalline. They're made of a bunch of tiny crystal grains smushed together. Chalcedony and agate are cryptocrystalline quartz. The crystal grains are so small they're microscopic, sometimes even nanoscopic. Chalcedony, chalcedony. I think both can be correct. You know, potato, potato. Then again, I've never heard anyone unironically say potato, so chalcedony. Meh. If the molecules are in a disordered or random arrangement, then the structure is sometimes called amorphous or glassy. Crystalline materials can be frozen in an amorphous structure if the liquid phase is cooled very rapidly, giving the molecules no time to rearrange themselves into a crystal lattice. Mixing in certain additives or modifiers can also disrupt crystallization. Silica solidifies as a glass very easily. Common glass is amorphous silica, mixed with a small amount of other oxides. Speaking of glass, obsidian is volcanic glass, typically originating from what is known as felsic lava, or silica-rich lava, sort of the opposite of the mafic lava mentioned earlier with olivine. These particular pieces are called Apache tears. They're found as nodules in solidified lava flows, lava domes, or ash flow tuffs. Shine a light through them and you can see that they're translucent, sometimes with a dull green color. Obsidian is glass born from fire, but opal is glass born from water. Trace amounts of silica dissolved in water get deposited in cracks and openings in rocks or fossils, filling the space. These particular pieces are minute seams of opal in sandstone. The color of many minerals comes from trace element impurities that absorb certain colors of light, but opal is different. Opal's color comes from microscopic structures that diffract or scatter light depending on color and illumination angle. This phenomenon is one example of what is known as structural color, and some especially well-ordered structures are called photonic crystals. Many researchers are studying ways to make photonic crystals and use them to build photonic circuits, circuits that perform computations by guiding light instead of electricity. One last rock. It's valuable and made mostly of carbon. 90% of coal comes from large forests that grew during the Carboniferous and Permian periods, around 300 million years ago. These forests were mostly composed of scale trees that could grow up to 50 meters tall and are actually relatives of modern club moss. Burning coal releases carbon into the atmosphere that hasn't seen the surface of the Earth since before even the first dinosaurs appeared. Okay, I know. Diamond is another rock made of pure carbon and might have been interesting to talk about. But now, you can legitimately tell people that you once received coal for Christmas. And you can blame me. Just remember that each of you is far more precious than any silly gemstone. So be kind to yourselves and others, and try to hold on to a bit of curiosity and wonder about the world. I love you, and happy holidays. Also, diamond is not forever. Diamond is made of carbon, so under the right conditions, it does burn. And 2, the thermodynamically stable form of carbon at room temperature and pressure is graphite. Diamond is technically metastable, meaning that you could argue that these precious stones are very slowly turning into pencil lead. So,